Hi everyone. In today's video, I want to talk about ziplining. So before we begin, I want to explain about what ziplining really is. Ziplining is an inclined cable or rope with a suspended harness or a pulley. In layman's terms, it's simply this. We have a higher surface here, and then we have a lower surface right there. And both these surfaces could be connected by a pulley, for example, that travels downwards, making an angle like this. And a person, John for example, slides downwards like that, from a higher position to a lower position. That's all ziplining is. Now, continuing on the introduction of what ziplining is, I want to explain to you guys how ziplining works. So ziplining works by causing the person A, starting at a higher surface, to slide down to surface B. The major force here at play is gravity. If we had a vertical force, which was just a horizontal force like this, the person would just be standing there with no motion at all. However, zip lines incline that horizontal plane by 4 to 8%, making an angle like this with the horizontal. This causes gravity to increase acceleration. The more you increase it, the faster it'll accelerate. However, 4 to 8% would be the most optimal, because if we go too far, it's going to end up catastrophic. Now, building on what I previously talked about how ziplining works, let's talk about the physics component of it now. 2/3 of a zipline, usually it's 2/3, sometimes it can be a little higher or lower, give or take a certain number. 2/3 of it is increasing. So we have three velocities when we're doing it. V1, where we're starting at rest and then we start increasing on our angled plane. V2, this is when the speed is greatest, at its absolute peak, after increasing for 2/3 of the ride. And then this part here, this down the slope component right there, this is when we start slowing down. As you can see, it's in the negative frame of reference direction. And then at the end of the ride, V3 will also equal 0. What this line, velocity line, let's call it, is telling us is, after we increase, we need a force in the opposite direction so that we can decrease in speed. To help you better understand this, I'll draw two free body diagrams. Alright, my first free body diagram will be when we're speeding up. Right. When we are speeding up, this will be our mass m, let's say. Force of gravity will always be downwards. Always remember this, unless you're in outer space or something. Now, when we're speeding up, acceleration is so great that it's much greater than the frictional force. So the frictional force, which is going the opposite direction we are, is much smaller because we're center seeking. Now, the normal force, if we're going this way, it's going to always be perpendicular. So if this was our line that way, perpendicular will be that way, forming a 90-degree angle. Now, you have to remember, since this is on an inclined plane, gravity has two components, the parallel and perpendicular component. So, the perpendicular component, again, is perpendicular, like the name suggests, with the horizontal. Parallel component is this. The free body diagram drawing for slowing down is very similar to this. Again, we have our person right here. Force of gravity is directed downwards. This time, when we're slowing down, the frictional force they've engineered on purpose to be much, much greater so that it slows down the ride. So now it'll go the same direction as our ride this way. And the normal force, again, perpendicular. And then we have our gravitational components, we have our perpendicular, we have our parallel components. These are the free body diagrams of when we're speeding up and slowing down. Now I'd like to talk to you about Newton's 3 laws and how they can relate to our zipline. Alright, Newton's first law. An object will always stay at rest or in constant motion or constant velocity unless a force is acting on it. If you put us on a zip line at an angle like this and you start ziplining, you will zipline forever. Naturally, you will zipline forever unless there are forces acting upon you. And thankfully, there are two primary forces. Number one, gravity. Gravity is the force that is pushing us down, that is making us go faster and faster. Gravity is 9.8 meters per second squared, which tells us that it is not constant like velocity. It can increase. The second is the frictional force. This is the most important force that is going to do the opposite of gravity's work. It's going to help us slow down towards the end. These two forces, gravity and friction, are the biggest components that play during a zip line. Now let's talk about Newton's second law. Newton's second law tells us the sum of all forces equals mass times acceleration. Now this one's actually very interesting because if we look at Newton's second law, heavier objects, which is m, let's rearrange it for m now. Net force over acceleration. The more heavy an object is, the greater angle it'll have with the horizontal. For example, someone lighter might have an angle like this, whereas a heavier person might have an angle like that. And what this does is, this will lose gravitational energy. And when we lose gravitational energy, that converts to kinetic energy. This is the reason we have maximum and minimum weights. Because if someone is over the limit, what's going to tend to happen is the frictional force for slowing down will be impacted due to, as you can see, the greater angle curvature. Now, if there's a minimum weight, there's also a high chance that it would be so light that they might get stuck in the middle of the ride. Now, this is the reason we have a maximum and minimum weight on our zip lines. Alright, before we finish up, I just want to do a sample problem to make sure that you guys understand everything really well. So let's read this. If the zip line has a 30-degree angle with the horizontal and the rider's mass is 85 kilograms, assuming no frictional force is at play, find the gravitational force and acceleration. First, let's start with gravitational force. We know that the gravitational force down the slope is mg sine theta. Let's write that down. Now, using our units we know, mass being 85 kilograms, gravity being 9.8 meters per second squared, multiplied by sine with our angle of 30 degrees, this should give us 416.5 newtons. This is our net force. Now using this, how do we find acceleration? If you remember earlier, acceleration is just equal to the net force divided by the mass. Therefore, acceleration will be 416.5 newtons divided by 85 kilograms, giving us an acceleration of 4.9 meters per second squared. And we are done. So this is how we can incorporate zipline problems into real life and how real life engineers might solve them too. So that is all for today. I really hope you guys enjoyed the video. Please like, share, subscribe, and hit the bell button down below for notifications. I will see you next time.